Hi everyone, it's great to be here. Thank you all for coming. My name is Amit Dayan, and I'm here to talk about the study that it was directed by Professor Raphael Sachs that's sitting here. It's about, like you said, cognition enhancement for apartment customization. We've done it using virtual reality. So maybe I start off with just some general description of the problem that we're currently talking about, and I'm really glad for the continuity that we have with the previous presentation that was very relevant. So just talking about customization in general, and this is something not reserved solely for apartment and not solely for construction. This is a trend that we see across other verticals, and we see it in fashion, in automobile, in furniture, etc. And this is a part of the individualization efforts that grow due to a noticeable demand that we see everywhere. And the reasons, we can talk about the reasons, but it may be cultural or other. The fact is that this trend here is existent, and it looks like it's here to stay. Talking about saturated markets, this is one of the aspects that led to this trend as construction companies try to differentiate themselves and gain a grab of market shares in the construction of apartments. And this was a very noticeable strategy that I've seen in different countries. Okay, next thing. So maybe I'll put a little disclaimer before I start. And this entire study is talking about the process of customizing apartments as we see it in Israel. I know it may be slightly different in other countries, but I think that everyone would be able to relate at least to some of it. So the question is there a problem first? What do we have to do, or what do we expect to see when we're talking about customizing an apartment? And the process should be really straightforward. There's a base design, the customer gets it, we expect him to go on, do his own work, come back with his change requests. The construction company should get it, place the orders, do the construction, and everybody should be satisfied. It's very easy, very calm process. What we see actually happens is all those red wastes that we, I don't want to say that we don't anticipate it, but we see it very vastly in all over the residential projects, that we have delays by getting the information from the clients. A lot of clarifications are needed. We see a lot of requests for changes upon other changes that were requested before, and the degree of customer satisfaction is compromised compared to the service that they are getting in this process. And we're basically asking, why is that happening? Yeah, it should be a simple process. So what we've done just to recognize the problem is we investigated a fairly large residential construction project. It was roughly about 1,000 apartments in this study, and we've taken the client changes data from Tidhar, the construction company that collaborated in this research. And what you're seeing in front of you is a graph that's saying how many construction or change orders did the typical client had requested. And we see that the most common client requests somewhere around 50 to 74 change orders. And that's a lot of information to develop, to process. Of course, a challenge to the construction company, but more important is a challenge for the client. Saying this, we must remember that the client's background is not a construction professional. We shouldn't expect him to have any formal knowledge or experience, and that basically means that tasks that relate to customizing an apartment that maybe we, that sitting in this room, see as simple, can be challenging for the typical client. Maybe a word about the tools that we're using. We're trying to make it even more challenging on our clients, and basically the medium that they consume in order to develop their change requests are the construction documents. And these documents are maybe the most flooded with information piece of paper that we can provide to them. Something really confusing that for someone who is looking at apartment floor plans in the first time. And on another note, this method is serving us since maybe the 80s, where it started off with CADs. And we're sitting here, we see that a lot of advancements have been done in other technologies that can serve this process, but it looks like none of them really infiltrated the field of apartment customization. Now, a word about cognitive learning. It's something that would be really challenging to describe thoroughly here, but just generally I would say that this is a term that is very coined and vastly adopted from consumption and retail-related research. It basically means that a client is more likely to communicate effectively and also enjoy such a customization process only if he gets to a critical level of familiarity and understanding of the product, which is the apartment, of course, in our case. And the contrary is also correct. One that misses on the cognitive learning side will likely act less effectively in the customization process, and we suspect that this is one of the root causes for the problems that I've described earlier. So who suffers? Of course, the first one is the client. It's the need to pay for additional products and services that are not necessarily required by him. He's wasting a lot of time in his home with his family about the customization process. This is not a very quick experience. And many testimonies that we've got from the service representative and the construction companies, they always talked about how stressful and emotionally charged is this process for the apartment clients. Of course, who else is paying the price of the construction companies that have to invest a lot of service hours facilitating these services, and they have to hire additional staff, maintain it with additional overhead, and it makes the core activity of the construction company, instead of being construction or production oriented, it gets more service oriented. So it kind of shifts what we're here to do. The compromised client experience I've talked about, and last but not least is the environment. Since we see a lot of change requests after construction has been done, this necessarily requires demolition many times. This is just pure waste that creates unnecessary emissions to the environment that we definitely should seek avoiding. So, what has the industry done until today? Everyone knows that there is a chaos in construction side and in the service offices due to the issue of customization. So we're just trying to control the chaos. And how do we do it? We apply those fancy information systems. We get really high-end service and managerial offers, the good staff to accommodate these processes. And the industry lives this way. But what if there was a possibility to avoid or at least mitigate some of the chaos that I've currently described? So this is what we have tried to demonstrate in this study or investigate. And the main question was, will clients' cognitive learning be enhanced by utilizing 3D virtual reality applications? And that's, of course, compared to other clients that will be using solely the traditional paper drawings without any virtual reality application. So this is the comparison that we have tried to do. And just in order to get such process running, we had to sort of improvise the VR app for this purpose. And we started off with the collaboration with Tidhar Construction, which you see we're collaborating throughout this study. They've provided us the fully detailed apartment that was under construction at the time. It had a Revit architectural model ready. Of course, we just had to accommodate it with additional graphics and visualization information, we call it the visualization model, and accommodated with some more supplementing information that I'll show in the next slide. We exported all this information to the Unity engine just to bring the gaming behavior to it. That's the user interface and the physical behavior, basically going from a three-dimensional model to something that physically interacts. And you exported it all to a user-friendly app that was just an executable. You can just put the Oculus Rift headset on, and it was fairly easy to run and use, even by a not so experienced user. So this is how it looked like. The participant had a dedicated workstation with the head-mount display. When I talked about the supplementing information, one of the things that we've seen is that a lot of the dimensions that we see on the floor plans is something that we don't see in the virtual reality, and it's information that is very much required. So we try to accommodate it into the model by supplementing those 3D graphics to give this supplementing information. It's also for the room labels that we see on the interior doors. This is how it started off, from the floor plans and the RCPs, and what we've measured. So, just like the former presentation, we've used the selection questionnaires in order to quantify this, the results that we're getting. We use the scale of 1 to 7 instead of 1 to 6. And we've targeted, since cognitive learning is such a wide field, we try to narrow it down to 3 specific aspects. It was first about the apartment's functionality. The second was about learning of dimensions and spaces. And the third was quantifiable things that you can actually remember from visiting the apartment, either by trying it on the paper drawings or on the virtual reality. Since many of the answers that we've got were really subjective, we couldn't really, there is no correct answer. So basically what we've measured is the participants' confidence and the reported ease of assessment. Lastly, the last question in the questionnaire was regarding the direct participants' perceived VR or drawings contribution according to their subjective feeling. And what you see here are the mean values of the different questions that we've got, but more interesting are the highlighted yellow dots that show the p-values, and you'd see that most of the answers that we've got are significantly lower. There's the variance is significant here. Most of the calculated p-values are below the 5% threshold. So just to conclude, we can say after this study we've got some strong indication that for enhanced apartment cognitive learning by using virtual reality compared to what we're currently doing with traditional drawings. And that was for the 3 aspects that we've measured: demonstrate functionality, demonstrate dimension, and deepen familiarity with the apartment as a product. By additional findings, I mean findings we have recorded through the study on a qualitative basis from the participants' responses. Although they were not asked directly about them in the questionnaires, but I still find them worth mentioning. So most participants expressed disappointment about the actual spaciousness of the apartment. Things that seem larger on paper seem smaller in the immersed experience. Navigation shift from drawings to immersed experience was also a bit of a surprise, because if you find it that looking at the floor plan, you see the entire apartment, you can see above the walls, but once people got into the virtual reality, they had to navigate their way in order to get familiar with the space. Regarding the via ease of use, we saw a great variance about some people taking it really naturally and feeling it really comfortable and started walking through the space very quickly. Some others needed some more facilitation or at least a basic training to get it done. And the last thing that some others mentioned is the side effect of dizziness. So currently with the head mount displays, I can say from this study that about the 10 minutes threshold is about what a person can take before getting too dizzy to go on this experience. So it's a little bit of, call it maybe a limiting factor. Thanks.